Assalamualaikum, good evening to Dr. Gohan. My name is Ahmad Zain, project manager from Group F. We are here to present our latest project, which is Tosika. So Tosika is a real-time office command filtering system designed to make online space safer. Our team consists of 5 members covering key roles, including project management, AI engineering, marketing, finance, and administration. So let's get right to it. Firstly is the problem statement. The social media right now is filled with toxic with hate speech, threats, and assaults. The main issue is scalability. Manual moderation is simply too slow to handle, and millions of comments posted every day. This lack has real-world consequences. Users face serious mental health issues, and platforms suffer from loss of reputation and trust. To solve this, we built ToxiGuard as an automated AI system designed to detect and flag toxicity in real time, removing the burden to the human moderators. Now we move to project management strategy. To ensure we deliver this solution effectively, we adhere to strict project management strategy, which is we utilize the PMBOK framework, organizing our workflow into 5 standard process groups, which is initiating, planning, executing, monitoring, and closing. We also establish clearly defined roles to ensure accountability. For example, assigning a dedicated engineer for encoding and treasurer to manage our budget. For our management stack, we rely on 3 key tools: ClickUp for scheduling and creating our Gantt charts, GitHub for version control and collaboration, and Google Doc for all our documentation and reporting. Right now, we are looking at our timeline, which is a Gantt chart. This Gantt chart visualizes our schedule roadmap. We kick off with initiating and planning phase. We are focused on assigning roles, approving the project charter, and defining our scope. The core of our work happened in the data preparation and model training phase. As you can see on the timeline, this involves critical technical tasks like data cleanup, SONGE, data balancing, and training multiple models including neural network and random forest. Finally, we move to the monitoring and closing phase, where we conduct cross-validation to ensure our forests. Finally, we move to monitoring and closing phase, where we conduct cross-validation to ensure our F-score meet our target before finalizing the project for GitHub upload and these presentations.
Now moving on to the methodology or the AI pipeline. First, we collected data. The data we used was from the Jigsaw Stocksin command dataset, which has around 30,000 rows of data. Next, we had to pre-process the data. This involved cleaning the text by removing special characters and URLs using regex. Thirdly, we did some feature engineering using Vader and TextBlock to detect the negative sentiment. And we also calculated the word counts and the comment length. Finally, we had to do some data balancing because the data set was not perfectly balanced. So we applied smoothing, which is a hybrid sampling technique to fix the imbalanced data.
Hello, Doctor. My name is Fauzi, and I will explain the technical optimization part. So first, we start by compare the two methods, which is the random forest and the neural networks. Initially, both models struggle with a specific category, which is the threat. The reason for this was because of the class imbalance. Because threats are rare in the dataset, the models were essentially ignoring them to achieve a high overall accuracy. To fix this, we didn't just guess the setting. We used a Keras tuner to automate the search for the best hyperparameter. This led us to our final architecture. Referring to the table there, we land a 3-layer dense network. Our first layer used 192 neurons, which scaling down to 64 in a second. In the second one. Okay, jap. Cut balik. As you can see in the table here, we have landed a 3-layer dense network. Our first hidden layer used 192 neurons and scaling down to 64 in the second layer to ensure that the model didn't just memorize the data, We implement a dropout rate of 0.4 and use the optimizer with a learning rate of 0.01 for efficient training.
Okay, my name is Muhammad Lazahad. I'm gonna talk about the result and the comparison. Okay, so after everything we did, 7 weeks of data prep, building models, and dealing with all the class imbalance issue, here is our actual result. We tested three different approaches to see which one actually worked best for detecting toxic comments. First, let's talk about the random forest. Random forest completely failed to on detecting threats. We will focus at it too first. We are focused at random forest too much because random forest usually works well, but then it makes sense. We had 3,000 total samples and only 15 of them were actually threats. So the model just didn't learn the threats very well. It basically said threats does not really exist in this data, so I'm not gonna bother trying to find them or anything like that. So uh, we switched to a different model, and that is a neural networks. But honestly, it had the same problem first. The same issue cannot detect threats enough from the data, but then we realized that we could solve this differently. Uh, like we try to create we try to find what if we just created more a thread example, so like synthetics one, so that is smoothing. We use smoothing is basically a technique that creates synthetic threads example by looking at the real thread and example at looking at the real thread we had and generating similar ones. So instead of 15 thread example, we end up with hundreds and plus to train on. And look at the neural precision on threads went to zero point 0.5, and we went from 0% ability to detect threat to 50%. That's the actual huge the huge gap between both of them. Of course, the recall is only 0.07, so we're only catching 7% of the all threats. But remember, the threats are super rare in real data, so the key thing is we are catching them out, and whereas random forest does not catching them at all. So all the threats we bypass random forest. And the other toxicity types are doing better. Obscene is 0.77 position. Toxic is 0.72. Insult is 0.67. So it working across the board. Um, Basically, random forwards could not handle how unbalanced our data was. It's a good algorithm, but it just doesn't work with extreme class imbalance. Neural network work with smoothing. They handle it. They actually learn to detect threats instead of giving up like random forest did. This is exactly what we wanted to show. We found a real problem, try to different solution, measure if they work, and neural network with smoothed actually perform better. It's not perfect, but it's working. So the bottom line is toxic guide detect toxic comment in real time. We put something that actually work for keeping online community safer. That's it for me.
Um, so let's forward to the challenges and solutions. We hit three main hurdles while building this project. Firstly, since we have so few threads example in the data, we use smoothing to generate synthetic data and balance things out. We also had to fight the overfitting, which is basically when the model actually start memorizing the data instead of actually learning. So we added dropout layers and use early stopping to keep it on track. And finally, to manage the complexity of the whole process, we use Keras Tuner to automatically find the best learning rate for this project.
So let's continue on the GitHub implementation of the toxic guard. So every coding will be handled all in the GitHub so that everyone can have access and check on the every update. So how things work is we can add the files in the GitHub and add the contributor or the related people to access the file. So every change, they can go through the process push and pull, where you can push the new update and the others can validate and pull and later merge the update into the current coding. So all of this function uh, communication will go through the comments and the issues function. So here's we submitting some comments on the issues function so that the others can also think and solve the issues together. So here's the solution. So all of the process of solving this project will be done in the GitHub.
So in conclusion, our project Toxic Guard successfully detected 5 types of toxic speech in real time. And we managed to deliver this project on time, which is 7 weeks, using zero cost tools. And we managed to complete this project using smoothing data balancing with neural network to create a robust filter for safer online communities. In the future, we may deploy this as a browser extension or even a mobile app API. Thank you very much.
Hello, so kita akan continue pada bahagian demonstration. So di sini kita boleh cuba text classification. Kita letak you. Okay, kita akan cuba. So here's the predictions. The three hits is 0.05%, insults 100%, since the toxicity. So we can also go test with I. So here's the result is there's none of the toxics or threats related in the test. So you can also further try. I will. So here the predictions. They identify the threats and the toxicity in the test. So lastly, we will try on this, and we will identify that these tests involving obscene, severe toxic toxicity and identified hits. So that's all for the demonstration. Thank you.